Hi everyone, and welcome to the second of two videos going through some past exam questions on the topic of covalent bonding. Most of these questions, as we've seen in the previous video, just tend to be dot and cross diagrams, and we've got another one here, dot and cross diagram for CO2. Okay, so we're going to have a carbon in the middle, bonded to the two oxygens. So then again, if we go back to the periodic table and have a look, oxygen is here in group 6, so it's going to have 6 in its outer shell. So therefore it needs 2 more electrons to get to 8 in the outer shell. As we talked about in the previous video, elements don't always have to have 8 electrons in the outer shell to be stable, but it's the most likely situation for them to be. If we can draw a dot and cross diagram where they do have 8 in the outer shell, then we should do that. So if we want to have 8 in the outer shell, it's already got 6, it's going to need 2 more. So it's going to need to get 2 electrons from the carbon. So this is going to have to be a double bond. And then the oxygen had 6 electrons, so we've drawn 2, 3, 4, 5, 6. And then we're going to have exactly the same situation with this oxygen. And then carbon is in group 4. It should only have 4 electrons in its outer shell, and I've already drawn 4 dots, so we're done here. We could also just do a check and make sure the oxygen has got 8, this oxygen has got 8, and the carbon in the middle has got 8. So they've all got 8 in their outer shell, so they're all going to be stable. Right, this is then asking us about silicon dioxide. It's saying it's got the same structure and bonding as diamond. So what is the structure and bonding? Well, hopefully we know about diamond from GCSE. Okay, and it's going to be a giant covalent lattice. Okay, and that's covered all of it because the bonding is covalent and the structure is a giant lattice. Right, we then have hydrogen chloride reacts with water to produce an ion with the formula H3O+. An H3O+ ion has one dative covalent bond. Draw a dot and cross diagram to show the bonding. Okay, so this is going to be very similar to a water molecule. So that would be a water molecule, but we know then it's bonded to another hydrogen. So it's going to be another hydrogen, let's say up here. And it's going to have a dative covalent bond. And we saw this in the previous video. Remember, a dative covalent bond is just a covalent bond where both electrons have been donated by the same atom. So if we were drawing a water molecule, hydrogen only has 1 electron, doesn't it? So it's just going to make a normal covalent bond. And the same with the other hydrogen. Oxygen, we've already seen from up here with our carbon dioxide question, that oxygen has 6 electrons in its outer shell. So it's got 1, 2, 3, 4, and then this is going to be our dative covalent bond. Okay. It doesn't say that we need to label it. I'm going to label it anyway, just to show you guys. This is our dative covalent bond. Okay, what has happened is that the water molecule has used the lone pair from the oxygen to make a bond to an H+ ion. The H+ ion has come from the HCl. Okay. And so we've ended up with this H3O+ ion. We should really put the brackets on to say that it's a positive ion. They won't penalise you for it in the exam if you miss that off, but we should do really because that is what it is. Okay, a couple more questions here to have a look at. We've got the same question that we saw in the previous video. This does come up quite a bit. So a dative covalent bond. What I'm going to put here is, in the previous video, the question had already told us what a covalent bond was, but here it doesn't. So I'm going to say just a normal covalent bond is a shared pair of electrons. But then if it's a dative covalent bond, or you can see it could also be called a coordinate bond. You do see dative covalent bond more often, but that is also an acceptable term. So it's a shared pair of electrons that have both been donated by the same atom. Okay, and then there's just a couple of questions here which sometimes can catch people out because we're now talking about ions. This whole questions are about covalent bonding, but it's now saying, okay, we've got NH4Cl, give the formula of the ions. Okay, so this is going to be the ammonium ion, NH4+, and the chloride ion, Cl-. And then it wants us to draw a dot and cross diagram to show the bonding in NH4Cl. Well, we've all been talking about covalent bonding. We're going to draw a covalent diagram, but what have we just written? We've just written down the formulas of two ions. So these are going to be separate ions. We're not going to have these two covalently bonded together. Okay, what we're going to have is an ammonium ion that we can draw a dot and cross diagram for, and a chloride ion that we can do a dot and cross diagram for. Okay, so our ammonium ion, ammonia itself, is just going to be 3 single bonds to the hydrogens, and then the ammonium ion, because nitrogen has got 5 electrons in its outer shell, this would be a lone pair from the nitrogen. So what it's done is it's made a dative covalent bond to an H+ ion. So here is our NH4+ ion, okay, and then we've also got our Cl- ion. So here what's happened is we've lost an electron from here somewhere. The electron that we've lost is the electron from the hydrogen, because it would have been an H+ ion. So the hydrogens here I've shown as dots, and the nitrogen is crosses. So the 1 electron from the hydrogen would be a dot, and then the other 7 from the chlorine, to make this a Cl- ion. Okay. So even though we're in a covalent bonding topic, they will sometimes mix and match ionic and covalent bonding, because we've had to do covalent bonding here, dative covalent bonding, to make this ion, but then this ion has done ionic bonding with the chloride ion. Okay. There's another example of this in this last question here. It's a bit of an unusual one. So we've got this barium oxide, well, it's not barium oxide, it's barium peroxide. And they've told us some information here. So they've said the peroxide ion has this structure. Draw a dot and cross diagram for this barium peroxide. Okay, well, we know again it's going to be like this. There's going to be 2 separate ions, right? Because they've told us about this ion here. So let's start with the barium. If you find barium on the periodic table, barium is over here in group 2. Okay, so it's going to have 2 in its outer shell, and therefore it's going to lose those 2 electrons and make a 2+ ion. So I'm going to draw my barium with no electrons in its outer shell, because it's lost the 2 that would have been in its outer shell, and it's going to have a 2+ charge. Okay. We could also draw it with 8 in the outer shell, but it's easier to draw it with none. And then we've got to draw this peroxide ion, but they've shown us what this is. Like, this is 2 oxygens with a single bond between them. Okay. So we've got 2 oxygens here with a single bond, as represented just by the line here. Then oxygen would have 6 electrons in its outer shell. So if this is my oxygen, I've got 1 dot, 2, 3, 4, 5, 6. And here I've got 1, 2, 3, 4, 5, 6. And that is not enough to fill the outer shells, but we know this is a 2- ion. Why is it a 2- ion? Because it's gained the 2 electrons that the barium has given away. One of those electrons is going to go here to fill up this oxygen's outer shell, and one's going to go here to fill up this oxygen's outer shell. Okay, but we've already used dots and crosses, so we need to use a third symbol here to represent the electrons that have come from the barium. So I'm going to use a square. Okay, but it doesn't matter. You can use whatever symbol you like, but you do want to use a different symbol to show that it's not electrons from this oxygen, it's not electrons from this oxygen, it's electrons from somewhere else, it's electrons from the barium. Okay. And then hopefully you can see that this matches up to what they've shown us. 2 oxygens with a single bond and a 2- ion, because it's gained 2 electrons from the barium.